This is Shakil Ahmed. In this tutorial, we will learn about zero-inflated and hurdle models. These are extensions of cone models when we have a large number of zeros in our data. So we can differentiate these two type of models. One is zero-inflated model, and the second one is hurdle models. In zero-inflated models, we categorize zeros into different types. One is structural zeros, and the other is sampling zeros. What is the difference between the structural zeros and the sampling zeros? Basically, when we talk about a structural zero, that will be always zero for a person. For example, if we are collecting a data on birth per woman, that is a count data, then an unmarried woman will always have a zero value, zero births corresponding to her. So that is a structural zero. But for a woman who is married and whose age is greater than 30, still uh, might have a zero birth. So that is a random zero. That is due to the sampling variability, as we are selecting a sample, and in that sample a woman has or a few women have no births. So that is we are expecting non-zero value, but that is zero. So that is called a random zero or sampling zero. So this is the difference between the zero-inflated structural zero and sampling zero. So in zero-inflated models, we first apply a binomial model to assess whether the zero is true or a structural zero or a sampling zero, and then a cone model is used to model the number of cones that starts from 0 and 1, 2, 3, like Poisson distribution, negative binomial distribution we can use. But in the hurdle model, we don't need to differentiate the zeros. We just take zeros as one category, and we just apply a binomial model or a binary type of model to check whether there is a zero or not, and a cone model that is truncated with positive numbers only. For example, that will start from 1, 2, 3, 4, 5. So to model the positive cones, we use a Poisson model or a cone model. So in both regression models, hurdle and inflated, zero-inflated models, we use uh, the binomial model and a cone model. So these are the combinations of basically a two-stage model. We are first applying a model on zero inflation, and then we are modeling the cones. So let's do this in R. We have again the National Health and Nutrition Examination Survey, a data set for 2017 and 18 cycle, and you just need this psych package, and I'm just importing data, and you can see the dimension of data, and the chronic counts are taking as the response variable. You can see, although there is no, there is not much inflated zero in this model, we are still we are using zero inflated models. You can just see the frequency of the cones, and you can see the histogram as well. That is by sex. You can find histogram directly for the chronic cones without stratifying by sex. So we have 7,000 zeros, and other numbers are relatively small, but still we can't say this is inflated zeros. In some data, we have, for example, 10,000 zeros and only 500, 300 other counts. Then we can say that this model is zero inflated. And we have tests as well to check whether there is a inflated zeros or not. You can test, and we will try in last. And you can just a Poisson model, run the Poisson model as we did. These are the results of Poisson model, and you can check the influence for the influential observations as well. But we are going for zero inflated models. And the first is zero inflated Poisson model. So in this model, this is uh, we can run under PSCL package. And when you run this model, this just zero in INFL, and the response is chronic counts, and ethnicity, sex, and income are the covariates. And I will just run this command, and you will see two portion of models. I think I just skipped the library. Now you can see the summary of the zip model. It consists of two parts. One is the zero inflated part, that is a log link. This is Poisson with log link, and this is a zero inflated model, that is binomial with log link. So we have two portions. One for inflated zero, how this X is affecting the uh, in producing a zero or not, that will be decided by this coefficient. And we are interested basically in these coefficients. These coefficients like ethnicity and sex and income. There are two categories of income. So we can see now ethnicity is significant when we remove the, when we adjust for the inflated zeros, the ethnicity is now coming as significant. And what does it mean? It means a one unit change in or the ethnicity uh, value, changing the value of ethnicity from one category to another. Although we need to just adjust the ethnicity as factor. So we will see three categories. I think ethnicity is not a dummy variable. So let's see what happened. Now we should have two categories at least, as ethnicity consists of three categories. So changing from the given category to from a reference category to the given category, we see how the rate of occurrence of the number of counts, average number of count is changing. Now you can see. Now we will we have all those five categories of ethnicity, as ethnicity is consist of six categories. So we are just comparing category 2 versus category 1, category 3 to category 1, and category 4 with category 1. So all our the categories are significant except of category number third. So these are all have a relatively lower uh, number of counts as compared to the base category, as the coefficients are negative. Similarly, the income, high income and low income is compared with the unknown category. That is not true, although you need to exclude the unknown category while analyzing for income. If you are interested in assessing the effect of income on number of counts, number of chronic counts of chronic condition, then you need to just have only one category, that is either it is high or low. Then we will have only one coefficient, that we can say that from low to high, what impact of income has on uh, chronic condition. So these are the coefficients which are produced after adjusting for inflated zeros. Uh, these are the coefficients, sorry, these are the zero inflation inflated coefficients, but these are the coefficients which are corresponding to the uh, cone model, and these are the coefficients corresponding to the zero inflated model. So zero inflated Poisson model just run the two parallel regression models, one binary that decides whether a zero is structural or random, and the other category uh, that is uh, whether an event occurs structural zero or a continuous with or a count with zero, that is deciding basically whether we need to stop if it is a structural zero or it is a usual zero or a count sampling zero or some other count. So we are just deciding on the basis of binomial logistic regression, and then a Poisson regression is used on the sampling zero and other counts, basically starting from 0, 1, 2, 3, and other numbers. And we see how the covariates are affecting the counts, average counts in the Poisson model. So this is the difference. Basically, we need to, while interpreting the result, we should keep these differences in mind. What is structural zero? What is sampling zero? And what is a hurdle model? And what is a zero inflated model? So you can just see the confidence interval for all coefficients for Poisson model as well as for zero inflated model. And we can report the results like this: estimates and coefficients and then their standard error. But we just need to report the result if we are interested in and assessing the effect of covariates on the count, then you just need to report the coefficients for corresponding to the cone model. Otherwise, if you want to show how the zeros are impacting or zeros are occurring, then you can show the result of zero inflation as well. And we can find the Zodo R square using, sorry, which tells how the model is overall significance of model, that is significant as with p-value, smaller p-value, as the likelihood ratio test suggests the p-value is very small. And you can also see the Zodo R square for different methods, and McFadden method, Cox and Snell method, and Nagle-Craig method, that is Craig and Euler method. So a higher R Zodo R square value suggests that the model is a good fit. Now you can just run similar model with zero inflated negative binomial. That is, we are just uh, accounting the inflated zeros as well as the over dispersion. So the zero inflated Poisson model only captures the inflated zeros, but when we have the problem of inflated zeros as well as the over dispersion, then we can run a zero inflated negative binomial model, which is just like a zero inflated Poisson model, and we are just replacing Poisson model by as negative binomial model. And you can see the results. We are just changing it by negative binomial NEGBIN by Poisson. And it's giving a warning. It means the diagonal of variance component is, uh, I think, negative. So the calculation may suffer from a problem, but we are still having a result that is the result of negative binomial, and this is the result of zero inflation model. Here, basically, the dispersion parameter is, I think, very small. That's why its standard error is uh, coming zero. Uh, Zero, or I think that is a type of negative number. That's why it's not showing. So you need to be careful while applying a zero inflated model. Uh, in this case, you just go for Poisson model, zero inflated Poisson model, and you can see the confidence interval, and you can again apply the uh, overall performance measures. You can see that is again significant, and we have Zoto R squares for using different methods. And the last thing we need to do is to check whether there is a zero inflation or not. Although there are tests are available, but you can just see with the histogram first. That will give an idea that we can see that there are a high number of zeros in this data. And the second thing, you can just compare the two models, Poisson and ZIP model. But keep remember that while comparing the two models, the one model should not be nested in the other model. There should be equal number of predictors in the two models. Then you can compare. So the Wang test suggests which model is better in terms of uh, AIC values and BIC values. So this shows that model 1 is better than model 2. It means H naught is rejected. It means the model, the two models are not equal, and it is suggesting that model 1 is better than model 2. It means the Poisson model is performing better rather than a zip model. So we need to proceed with zero uh, instead of zero inflated Poisson model, we just proceed with Poisson regression model. So that's all about zero inflated models, and the things you need to remember, uh, you need to keep in your mind that just I will show the p-value suggests that there is a significant difference in the AIC and BIC of two models. Since ZIP has both a cone model and a logic model, each of the two models should have good predictors. And the two models don't necessarily need to use the same predictor. You can use different set of predictors in the inflated model and the cone model. But if you see in this command, we can't differentiate we can't use different and number of predictors in the two models. So we are keeping the same predictors. Other commands are available that in which you can set different number of predictors in and different own model and the binomial model. And problem of perfect prediction separation or partial separation can occur in the logistic part of the zero inflated model that we see. Uh, there may be a cause of perfect prediction means the zeros are perfectly predicting in zero inflated model, and that could be a problem. And Con data often use exposure variable to indicate the number of times the event could have happened. And you can incorporate a logged version of the exposure variable into your model by using the offset option. You can also use the log of some exposure in you include in your model. So that will be a that will give you a coefficient, constant coefficient of one that we are fixing if you are setting a variable as offset. It is not recommended that zero inflated Poisson model be applied to small sample as we need to estimate a lot of uh, parameters. So there should be enough sample size while applying a zero inflated model. Zodo R squared values differ from OLS R square. Please, you can see the uh, tutorial on uh, what are Zodo R's, what is zero R square. And I can share the link if you are interested, you can see. And Wong test is used when you have not a nested nature of models. The two models are should have same number of variables. So that's all about. In next video, I will discuss hurdle cone models. That is a little different with the Poisson model, although the interpretation is almost same. Thank you for watching the video, and don't forget to subscribe the channel. Thank you.